Over the planetary system, and there are at least three celestial bodies within the habitable zone. Now let's look at it in more detail.
Welcome back. Welcome back to Goddess Lala. And also welcome back to Mama Lala. Welcome back to Big Mama Lala. Goddess Lala is my other channel. Check out my other channel, Goddess Lala, for tarot card readings. This is my entertainment video. So excuse me if I say Goddess Lala. This is Star Diamond's channel. And this is the Big Mama Lala TV show. I will have different TV shows. This is the part two of a journey beyond the Milky Way. We're starting back again with the TRAPPIST 1 galaxy.
Single star with a planetary system, and there are at least three celestial bodies within the habitable zone. Now let's look at it in more detail. The distance between TRAPPIST 1 and our Sun is 39.5 light years. The object was discovered in the period from 2016 to 2017. This single star is a red dwarf of spectral type M8b. As for its dimensions, it is only 12.1% of our Sun's radius. Just to compare, it isn't in fact much larger than Jupiter. The mass of TRAPPIST-1 is 27,000 times that of our Earth, but at the same time is 0.08 the mass of our Sun. With the average temperature reaching 2500 kelvins, its luminosity is 1900 times weaker in comparison with that of the main star of our system. The orbital period of TRAPPIST-1 is 3.3 days. As for its age, it is 7.5 billion years, which makes it almost 3 billion years older than the Sun. The distance between this star and us is diminishing, as it is slowly but surely drifting towards our system. This object aroused interest largely following the discovery of its planetary system back in 2016, whose three components were spotted by transit method with the help of an automated 0.6-meter telescope in the European southern. Monday.com makes scans great. So, in Chile, the planets were initially dubbed TRAPPIST-1b, TRAPPIST-1c, and TRAPPIST-1d. However, further investigations revealed that the presumed location of TRAPPIST-1d was described incorrectly. Following that, four more Earth-like objects were discovered by astronomers with the help of the Spitzer Space Telescope. These were dubbed TRAPPIST-E, F, G, and H. Thus, the total number of planets in the system reached 7, and on the 13th of April 2016, the parameters of these celestial objects were defined in more detail. All the seven exoplanets are identical to our Earth in terms of their dimensions, with their radii ranging from 0.71 to 1.13 that of our planet. Planets B and C orbit their parent star in the periods of 1.51 and 2.42 days respectively. Initially, according to astrophysicists, both of these planets were comparable to Venus in all but exceptionally high temperatures. However, after their mass and density had been measured, it was TRAPPIST-1 that could be called Venus's analog. TRAPPIST-1b, the second closest planet to its star, is likely to contain a large amount of water and other volatile elements. The new data enabled scientists to find out more about the other discovered planets too. It takes TRAPPIST-1d 4.05 days to orbit its star. Its radius is 0.77 that of the Earth. The orbital period of
777.
TRAPPIST-1e is 6.
777. 6 and 1 is 7 2. 777. Check out the numerology. Goddess Lala does numerology too. Check out my other channel, Goddess Lala. Thank you for watching. Thank you for watching. Thank you for watching Big Mama TT TV. Thank you for watching Big Mama TV. Thank you for watching Big Mama Lala TV. 777 is Big Mama Lala's number. 777 is Lala number. Yes, like I said, numeration. Check out the numeration in my videos. I also do numerology celebrity readings at Goddess Lala channel. I have Goddess Lala channel. And thank you for watching the Star Diamonds TV channel. Thank you for watching Star Diamonds channel.
which makes them considerably lighter than thought previously. As for the furthest of them, E, F, G, and H, for all we know, they may consist entirely of water. Only TRAPPIST-1c boasts a mass bigger than initially estimated, which may be indicative of over 50% of iron in its composition. Of the 7 planets known to be located in the TRAPPIST-1 system, 3 of them find themselves within the habitable zone, namely D, E, and F. Speaking about the rest of them, following the estimates of its density, planet B is thought to contain either a small nucleus or else a considerable amount of volatile elements. Due to high temperatures of 127 and 69 degrees Celsius above zero on the surfaces of planets B and C respectively, water is not likely to remain in its liquid state there and is bound to float about as vapor. As for planets G and H, they are too remote from their central star to be potentially habitable. However, according to models suggested at Cornell University, the habitable zone of TRAPPIST-1 may well be wider, and allowing for volcanic hydrogen potentially acting as a greenhouse gas, there may be 4 planets within the habitable zone rather than 3. The density of TRAPPIST-1f is rather low too, and so it may well turn out to be an all-ocean planet. Here are the temperatures for all the planets in the system. The steady-state temperatures are given without including incident light dispersion and greenhouse effects. Just to compare, the steady-state temperature on our planet in the same conditions would measure 4 degrees above zero, and on Mars 47 degrees below zero. In November 2017, it was posited that the activity of this star didn't allow its planets to form and maintain their own atmosphere. It is accounted for by the fact that TRAPPIST-1 goes through periods of active flares, which may negatively affect the nearby celestial bodies, and thus render them uninhabitable for living organisms as we know them. Interestingly, the planets are located much closer to each other in comparison to our system's planets. The planet Mercury, which is the closest one to the Sun, is located 0.39 astronomical units from it, while the distance between TRAPPIST-1b and its parent star is just 0.01 astronomical units. As TRAPPIST-1 is a rather dim star, it is no easy matter to explore it. Red dwarfs like that are quite widespread across the universe, accounting for most of the galaxy's stellar matter. Plasma ejections on these stars are a rare occasion, although astronomers believe that there may be giant cold areas and compact hot areas with temperatures upwards of 4,000 kelvins on the surface of TRAPPIST-1. If this conjecture proves to be true, scientists will proceed to confirm that the system's planets are constantly bombarded by powerful ultraviolet and X-ray radiation, which is able to destroy their atmospheres and render their surface completely sterile. The reason for that lies in the fact that none of the microorganisms known on the Earth are able to withstand intensive radiation emanating from flares of this kind, including the most radiation-resistant bacteria Deinococcus radiodurans. Nevertheless, in December 2017, atmosphere was proven to persist even in periods of high activity of stars, which implies that planets G and H may potentially have their own atmospheres. At the moment, astrophysicists' idea is to use more up-to-date telescopes for studying the matter. For example, the James Webb Space Telescope, whose launch is planned for March 2021. Today, the TRAPPIST system presents a great interest for the global scientific community, and even though it is highly unlikely that any advanced civilization will be discovered on its planets, we cannot ignore the fact that life forms in the universe may be extremely diverse and may differ from our perceptions of life as we know it, which implies that not all intelligent organisms are supposed to follow the scenario of our planet. If science manages to find out more details about this system in the nearest decades, many conjectures and doubts we have today about TRAPPIST-1 will most likely be cleared. mankind has come across some extremely powerful radiation that reached us from deep space several times in the last 50 years.
Like and subscribe. Like and subscribe to support this channel. When you like, more people can see the Star Diamonds channel. Like and subscribe so more people can see Star Diamonds channel with great content for family also. The whole family can watch. Great content.
1992, astrophysicists assumed that there was a celestial object out there not known to science with a huge
Subscribe.
electromagnetic radiation coefficient.
Subscribe so you don't miss out on any more of my new videos.
Devices registered an unaccountable anomaly with its source located tens of thousands of light years away from us. 2004, all telescopes in the world were for a short time dazzled. Less than a second later, every cubic centimeter in the solar system experienced a wave of gamma-ray radiation, the most massive burst in the
Gamma
entire
ray.
history of observations. And today we're closer than ever to finally putting our finger on the nature of this discovery. A magnetar is a neutron star with an exceptionally powerful magnetic field of about 10 to the power of 13 teslas, which in essence is trillions of times that of the electromagnetic radiation on the Earth. It is also one of the rarest and really most dangerous phenomena ever encountered by mankind. When a supermassive star is on the point of dying, a supernova occurs. Among the multiple scenarios of what may take place after that, only one may lead to the star becoming a magnetar after the supernova. Many of you would have heard about the Russian roulette at least once in your lives. According to the rules, only one cartridge is put in the revolver's cylinder. The chance of producing a shot after you have spun the cylinder is rather small. However, when it does happen, the consequences are truly mind-blowing. Be it as it may, scientists are still at odds over what exactly this scenario would look like. According to the first theory, it's the inner energy of the star and its rotational energy that influence the formation of a magnetar. If a neutron star is formed at the time of fast rotation, the inner energy of this star, as well as its rotational energy, which is of great significance in the first several seconds.
If you had gotten in early on stocks like Apple,
Like and subscribe. Thank you so much. Subscribe to support this channel and so you don't miss out on any more of my great videos from Mama LALA TV. Big Mama LALA.
trading at just $4 right now.
All create a powerful magnetic field. This process is known to science as a dynamo mechanism. But there is another theory as well. After the accretion process, the magnetar may be able to receive energy from another star. Scientists have discovered a magnetar which is on an escape trajectory from our galaxy. Most moving stars we know set off on their trajectories as a result of supernovae in binary systems. This means that the accretion process takes place between the two stars with a common mass center in a binary system. Matter from one star gradually flows to the other. In this case, this is the source of energy for a potential magnetar. Something similar happens with a basketball spinning around the edge of the basket. Sooner or later, it is going to fall, but it's the spinning process that predefines the direction of the fall. Magnetars spin on their axes extremely fast, with a speed varying between tens and thousands of times per second. At the same time, their dimensions are record small. As a rule, the diameter of a magnetar reaches a measly 20 to 30 kilometers. Just to compare, the diameter of the moon equals 3,474 kilometers. That is about 173 times that of the average magnetar.
7773.
The mass, however, is a completely different matter.
That's the Lord's number.
A magnetar with a diameter of 15 kilometers will be
777.
significantly
Allah
heavier than our
Akbar.
Sun, despite the dimensions. It is its staggeringly powerful density of the interior that is the reason for its high magnetic radiation. For instance, 1E1048.1 - 5937 is an anomalous X-ray pulsar located 9,000 light-years away in the constellation Carina. The star the Magnetar evolved from had the mass 30 to 40 times that of our Sun. The matter in these stars is dense to such a point that a fountain pen cap would weigh billions of tons, and a human would be torn to bits within a matter of seconds after landing on the star's surface. Several years ago, astronomers from NASA managed to register a phenomenon which came to be known as a starquake. Thanks to the Fermi Gamma Ray Space Telescope, scientists received data about intense X-ray bursts. Their source was magnetar SGR J1550-5418. The magnetic field of this star is so powerful that from time to time its crust bursts with vast amounts of energy released through the crack. Such starquakes are the source of pulsed electric current. In theory, if a magnetar of this kind, at its most active, were to find itself within the boundaries of the solar system, we wouldn't as much as notice the threat, as the ozone layer of the Earth, together with all organic life forms, would be wiped off within a matter of a few hundredths of a second. Fortunately, however, the magnetar closest to us is a safe enough distance away. A magnetar is hard to approach not only due to the gravitational properties of its core and energy flares at the time of a starquake. When a magnetar is in its stable condition, its magnetic field is able to mess with electric devices hundreds of thousands of kilometers away, and within the radius of 1,000 kilometers, any object would be reduced to atoms. In order to systematize the difference in their radiation, scientists decided to divide magnetars into two varieties by using abbreviations. Rather than the full names, you will see these in any astronomical catalog. SGR, soft gamma repeater, and DXP, anomalous X-ray pulsar. In essence, SGR and DXP are different phases in the life of one and the same object. According to scientists, a magnetar exists as an SGR pulsar for the first 10,000 years. That is, it's a pulsar visible in regular light and repeatedly emitting bursts of soft gamma rays. As time goes by, it exhausts its properties and recedes into the invisible spectrum, when it can be seen to us only in the X-ray range, as an AXP. According to different sources, today among billions of neutron stars, the number of known potential magnetars ranges from 30 to 150. There are about 12 of them in the Milky Way. The magnetar is a soft gamma repeater, and if a starquake were to take place on its surface, it would affect us only by some slight changes in the top layers of the ionosphere. Due to their small dimensions and remoteness relative to the Earth, magnetars cannot be observed through regular amateur telescopes. The method of infrared or X-ray scanning of the sky is usually employed to observe them. Nevertheless, thanks to their active magnetic field emission and radiation, these stars are much easier to detect with the use of various instruments. This is exactly what took place several years ago. In 2013, astronomers claimed to have discovered a magnetar in close proximity to a supermassive black hole right in the middle of the Milky Way. The star was detected thanks to several orbital telescopes, including the Chandra X-ray Space Observatory. SGR 1745-2900 is only 0.3 light-years away from the edge of the black hole, and to date it remains the only neutron star to have been discovered in close proximity to an object of this scale. SGR 1745-2900 has been observed by scientists ever since its discovery. Several years ago, the level of its X-ray radiation was proclaimed to be significantly lower than that of the stars of this category. The news prompted numerous debates. Can these changes have been caused by the black hole in the star's environs? After 2 years of observing SGR 1745-2900, astrophysicists came to the conclusion that all things considered, The distance of zero point 0.3 light years is insufficient for any interaction in the magnetic or gravitational field to take place between the black hole and the magnetar after all. The reason is likely to lurk elsewhere. A magnetar's lifespan is quite short, just about 1 million years, and it's quite natural for its magnetic field to gradually die down throughout the star's existence. Some scientists assume that these processes may be the reason for the change of the star's status. In this case, magnetars can switch their category, flare up more frequently or less often, deplete the stock of the matter, and thus go from the category of SGR to the category of AXP. In its autumn years, a former magnetar that managed to survive the dissipation of its magnetic field may even become quite a different kind of star, namely a thermally emitting neutron star. So far, just about 7 objects of the kind are known to science. For their number, this group has been dubbed the Magnificent Seven, and each of them may once have been
7.
one of the most dangerous objects of deep space.
Okay.
But in order to establish that, it will take us long years, further technological advancements, and dedicated people willing to devote their lives to searching for solutions to the most dangerous and incredible mysteries of the universe.
Hey, they say it was dangerous. 7, the Lord's number 7.
Eerie celestial
Ton. Hey, ton. Ton.
considered impossible until only recently, when on the 10th of April 2019, the National Science Foundation in the USA showed the world an image revealing a black hole in the middle of the Messier 87 galaxy. This
87.
object has a mass approximately 6.6 billion times that of the Sun, with a diameter of about 100 billion kilometers. Just to compare, the diameter of the Earth is only 12,742 kilometers. This hole falls into the category of supermassive black holes. A similar object can also be found in the center of the Milky Way. It is called Sagittarius A and boasts from 2 to 5 million times the Sun's mass, according to different estimates. The diameter of Sagittarius A is 45 astronomical units. In other words, 45 times the distance from the Earth to the Sun. But is it possible to admit of the existence of even larger black holes in space? And which of them is the largest? Let's figure it out. A black hole is a term referring to an area in space with an incredibly powerful gravitation in the center. As a rule, these
Do you see this war behind me? Me and my twin.
Thank you for watching. Like and subscribe.
These objects are rather small at first and are able to expand as they actively build up their masses. Black holes are categorized according to their masses. The heavier ones are called supermassive black holes. At the moment, scientists haven't formed a unanimous opinion as to how these objects come about in space. According to the most popular theory, that of gradual expansion, when a black hole appears, it has a mass typical of a star, and later on it grows by sucking in the surrounding matter. The amount of information accumulated by science about these objects is rather scarce, but even based on the current data, a supposition can easily be made about there being at least several such holes in the center of any large galaxy. In the time the universe has existed, a few million or even billion of black holes are likely to have been formed in it by now. At least today, only a small fraction of them is known to us. The champion in terms of its mass is the black hole in the center of a quasar known as TAN 618. This object was stumbled upon in 1957 when white dwarfs were being explored, and initially caused a lot of puzzlement on the part of the scientists. The notion of quasars was to appear only 6 years later. That is why the nature of the object was rather vague. On photographic plates taken with a 0.7 meter Schmidt telescope, It was listed as number 618 and described as decidedly violet.
Mm.
It was only in 1970 that radio emission from Ton 618 was discovered at the Institute for Radio Astronomy of Bologna. This emission was indicative of the fact that it was a quasar, and moreover, the most luminous quasar known to science at the time. It is assumed that there's an accretion disk of hot gas in Ton 618 surrounding a gargantuan black hole in the center of the galaxy. The gas must move around the disk at a tremendous speed, reaching 7,000 kilometers per second. This object is located in the constellation of hunting dogs, or Canis Venatici, and is 10.37 billion light-years away from us. The galaxy containing Ton 618 cannot be seen from the Earth due to the luminosity of the quasar itself, which is 140 trillion times as intense as that of the Sun. The contemporary review on quasars defines them as active nuclei of galaxies at the first stage of their formation. The nuclei's supermassive black hole sucks in the surrounding matter, thus forming an accretion disk. This disk is the source of luminosity of enormous power that is sometimes more intense than the aggregate luminosity of all stars and galaxies like ours. The brightest quasar, which was discovered in January 2019, has the luminosity of about 600 trillion suns and is 12.8 billion light-years away from the Earth. What could be the mass of an object finding itself in the center of a light cannon like this? According to today's estimates, the mass of the black hole in the center of the Ton 618 quasar reaches 66 billion times the Sun's mass, which makes it the heaviest black hole in our galaxy known to science. Black holes of this mass are categorized in a different group and are referred to as ultramassive black holes. In fact, the Ton 618 quasar isn't the only object in this category. Within the constellation of Cancer, for example, which is 3.5 billion light-years away from us, the OJ287 quasar is to be found. It has a black hole in the center and is 18 billion suns masses. In the center of the Phoenix cluster, there's a rapidly expanding black hole, which at this moment is 20 billion times the sun's mass, building up 60 suns masses a year. One of the best-known black hole giants is located in the galaxy NGC 1277 within the Perseus constellation. The object reaches 21 billion suns masses, and its event horizon diameter equals 130 billion kilometers, which is 15 times the distance from Neptune to the Sun. However, at the moment, this giant practically isn't being active. Speaking about size, the undisputed holder.
Yeah, I'm not that active now either. 7. 7 is my number, according to my first name. I'm not giving my first name out, but my first name has 7 letters in it. 7. Some of you might have figured out my first name already. But my nickname is Big Mama LALA. A lot of people call me LALA. You turn the L's upside down and 7. That's why I'm so happy about when they keep saying 7. Yes.
Today's estimates, the event horizon of this black hole could be as big as to accommodate our Sun and all of its planets. Its diameter is approximately 790 astronomical units. The Helmberg.
If you want to see the whole video of this, you can check out my playlist. Star Diamond's playlist, Star Diamond's channel playlist. Or continue to watch this video over again. Make sure you check out part 1. Make sure you check out part 1 of this. This is part 2. Make sure you check out part 1 of A Journey Beyond the Milky Way with Big Mama LALA.
Complex and detailed modeling. Scientists are going to collate the results of theoretical calculations with practical observations in the future in order to try to establish how exactly it was possible for a tremendous black hole to come into being inside the two galaxies on their collision. In comparison to the objects mentioned above, our own planet may seem of no significance at all on the overall